Okay, next, during the steps 4 and 5, formation of alpha-ketoglutarate, it happens in this isosaccharic dehydrogenase ICDH. It catalyzes the conversion of oxidative decarboxylation. Again here, carbon dioxide is removed from isosaccharic to oxalosuccinate and then to alpha-ketoglutarate. Let's see in the cycle. What happens? Oxalosuccinate, isosaccharic is converted into oxalosuccinate in the presence of ICDH, and the NADH is released along with hydrogen ion. Again, ICDH, it acts over oxalosuccinate to produce alpha-ketoglutarate, and there is a removal of carbon dioxide, or this is decarboxylation step. This is all summarized in step 4 and 5. It is said that formation of NADH and the liberation of carbon dioxide occur at this stage, stimulated or cooperated by isosaccharic NAD plus, Mg2 plus, ADP, Ca2 plus. It links the whole process. This step is inhibited by NADH. Inhibited by NADH means when NADH is produced there, this step stops, and there is no more conversion of isosaccharic to oxalosuccinate and then to alpha-ketoglutarate. Step 6 is the conversion of alpha-ketoglutarate to succinyl coenzyme. Let's say during the cycle, what happens? Alpha-ketoglutarate, in the presence of alpha-ketoglutarate dehydrogenase enzyme. Dehydrogenase enzyme means again NAD plus is converted into NADH plus H plus positive ion, and carbon dioxide is again released. This is the respiration process actually. That's why carbon dioxide is released during most of the steps. And this is converted into alpha-ketoglutarate is converted into succinyl coenzyme A. Let's see what happens during the reaction. Step 6. Conversion of alpha-ketoglutarate to succinyl coenzyme A. It occurs through oxidative decarboxylation catalyzed by alpha-ketoglutarate dehydrogenase complex. Alpha-ketoglutarate dehydrogenase is a multi-enzyme complex. At this stage of TCA cycle, second NADH is produced and the second carbon dioxide is liberated at the 6th step. 7th step is the formation of succinate from succinyl coenzyme A in the presence of succinate thiokinase. This reaction is coupled with the phosphorylation of GDP to GTP. This is substrate level phosphorylation. GTP is converted into ATP by the enzyme nucleoside diphosphate kinase and GPK. Let's see the reaction. Succinyl coenzyme A, in the presence of succinate thiokinase, it is converted into succinate, and GDP is converted into, along with the addition of another P, it gets converted into GTP here. Let's go to the 8th step now. Conversion of succinate format to fumarate. Succinate is oxidized by succinate dehydrogenase to fumarate. This reaction results in the production of flammine adenine dinucleotide hydride. From it in vanilla seed. Then we'll talk about the 9th step. Here, in the presence of succinate dehydrogenase enzyme, FADH2 is converted into FAD. There is the reduction process from succinate to fumarate, and fumarate in the presence of fumarase, it releases water and it is converted into malate. The enzyme fumarate catalyzes conversion of fumarate to malate with the addition of water. And next step is the conveyor, or the last step is the conveyor of malate to oxaloacetate. Malate is then converted into oxaloacetate by malate dehydrogenase. The third and final synthesis of NADH occurs at this stage. Oxaloacetate is regenerated, which can combine with another molecule of acetyl coenzyme A and continues the cycle. That's the whole process of Krebs cycle actually. Again, malate is converted into oxaloacetate, and NAD plus is converted here to NADH, and this oxaloacetate is again available for the whole cycle again, along with the combination of acetyl coenzyme A to produce a trade in the process of synthase. Well, this cycle continues, and this is the whole process of tricyclic acid cycle. This is very simple and easy one. Regeneration of oxaloacetate. The TCA cycle basically involves the oxidation of acetyl coenzyme A to carbon dioxide with the simultaneous generation of oxaloacetate. There is no net consumption of oxaloacetate or any other intermediate in the cycle, because everything is regenerated again and again. Only carbon dioxide is produced, NADH is produced. Complete oxidation. Significance of the cycle is complete oxidation of acetyl coenzyme A, ATP generation, final common oxidative pathway, integration of major metabolic pathways which are happening in the matrix of the mitochondria. Fat is burned on the wick of carbohydrates. Like carbohydrates mean glucose, it helps burning the fats, because ATP this conversion is possible because from glucose pyruvate is produced. Pyruvate is then used in the Krebs cycle or TCA cycle. Excess carbohydrates are converted as neutral fats. No net synthesis of carbohydrates from fat is shown there. Otherwise, carbohydrates, they can be stored as converted as neutral fat, but no net synthesis of carbohydrates from fat is observed. Carbon skeleton of amino acid finally enter the TCA cycle. Amino acids can also be used in the TCA cycle. Requirement of oxygen by TCA cycle. There is no direct participation of oxygen in TCA cycle. It operates only under aerobic conditions. ऑक्सीजन यूज़ नहीं होती है, लेकिन ऑक्सीडेटिव कंडीशंस में, एरोबिक कंडीशंस में ही रिएक्शन होता है. This is due to NAD plus and FAD required for the operational cycle can be regenerated in the